This is problem number 9 from section 9.1. In this problem it says, with a tailwind, a small aircraft can fly 1,200 miles in 5 hours. Against the same wind, the plane can fly the same distance in 6 hours. Find the average wind speed and the average airspeed of the plane. So there's two things they want us to find here. They want us to find the average wind speed and the average airspeed of the plane. So let's mark X as the, we'll call it the average wind speed. And we're going to call Y the average airspeed. Now, one thing I want you to understand about flying the plane, if you have your actual speed is going to be dictated on the wind speed plus the airspeed, or a negative wind speed if you're going into the wind plus the airspeed. So either the wind's helping you by adding to your speed, or the wind's hurting you by subtracting from your speed. So that's one thing to understand about things that are flying in the air, is the wind has a big, significant difference on your actual speed that you're flying. That's why when if you've been on a plane before, that's why you can get, sometimes your flight takes a little longer going to the place you're going versus coming back because of going into the wind versus being with the wind. So it says, with a tailwind, a small aircraft can fly 1,200 miles in 5 hours. So we're going to set up an equation where we know that we flew 1,200 miles. Okay? So one equation we know we're going to say equals 1,200, and we're going to call this going, and then this is coming back equation. Now, when we were going, we knew it took 5 hours. And coming back, it took 6 hours. Okay, both of those, though, were the same amount of miles, 1,200, right? And we can see that in that picture there. Okay, so what happened when we were going and it took 5 hours, which was an hour less? Well, we took our average speed for the wind, and we add it with our airspeed, and that gave us our total speed flying. And if we take speed times time, we get distance. So I'm going to multiply this times 5. So our equation is 5 hours times the two speeds being added together, right? Because the wind was blowing the same the whole time, theoretically, and the airspeed was the same the whole time, theoretically. Coming back, same idea though. Except for we take our speed, which is our airspeed, and I could do it either way. So our airspeed is Y, and we subtract out now our wind speed because our wind is hurting us, right? It's slowing us down. But we multiply that by 6. Now I could have wrote this as negative x plus y here to kind of mimic what I did over here. I just wrote it y minus x just because I think it makes most sense saying the airspeed minus the wind speed. Once you have those two equations written, you can see we have x and y in each of those. I'm probably going to use, elimination to solve this. So let's go ahead and distribute the 5. So we get 5x plus 5y equals 1,200. 6y minus 6x equals 1,200. Let's go ahead and rearrange this and set it underneath this equation. So we're going to have 5x on top, negative 6x on the bottom, plus 6y equals 1,200. I'm going to cancel out the x terms. So I'm going to multiply the top equation by 6 and the bottom equation by 5. And this is going to give you 30x plus 30y equals 6 times 1,200 is 7,200. 5 times negative 6x is negative 30x plus 30y equals 5 times 1200 is 6,000. Let's add the equations together. This gives you 0. This gives you 60y. And this gives you 7,200 plus 6,000, 13,200. Now we're going to divide by 60. And y equals 13,200 divided by 60, 220. So the airspeed average, 220, is the average airspeed. Okay, what's the average wind speed? Well, we go back to one of our equations, and it doesn't matter really which one. Let's go back to this one, though, that's sitting right here. Let's plug 220 in for y. We get 6 times 220 minus 6x equals 1,200. 6 times 220 is 1,320 minus 6x equals 1,200. Subtract the 1,320 over, and we get negative 6x equals, that'd be negative 120. Divide by negative 6. And we get 20. So x equals 20, and this should say mph. mph, 20 miles per hour, is average wind speed. So once you have the equations set up, it's pretty straightforward how to solve each of these. Hopefully that makes sense.